Thank you for joining us for this video. We're going to discuss solving trigonometric equations. All right. Trigonometric equations are nothing more than equations such as what you see down here. I'm going to work through solving the equations first before coming back and discussing the steps, because the steps really are solving any equation as you normally would, but we're going to look at our point of emphasis for it. So if we're trying to solve the secant of theta is equal, the secant of theta minus 2 is equal to 0, we can rewrite this as the secant of theta is equal to 2, which means that the cosine of theta must be 1/2 because the cosine of theta is the reciprocal of the secant of theta. Then, from the unit circle, we know that in the first quadrant and in the fourth quadrant, our cosine ratio is going to be positive, and we know that our reference angle for the cosine of theta to be 1/2 is going to be pi over 3 if we are in radians. So if we're solving for this in radians, right, we're going to have that theta is going to be equal to pi over 3, right? But also theta could be 5 pi over 3. And these will be our solutions that we're saying that, hey, our theta is going to be between 0 and 2 pi. Okay. Now, what if instead this asked us, it told us that theta was going to be between negative 180 degrees and 180 degrees? If that was the case, right, then we know our reference angle, instead of radians, we would be in degrees, which would be 60 degrees. And we'd be able to say, hey, that theta is equal to 60 degrees, or theta is equal to negative 60 degrees, because of the interval it's asking for our solution. So when we're solving our equations, we want to be aware of any interval that we're given. And our initial intervals will be provided. If they're not provided, we'll give them to you. So, for example, let's say that this one we wanted to have our interval be between 0 and 360 degrees, inclusive of both endpoints. So we have the tangent squared of theta minus 1 is equal to 0, right? If I rearrange, that means that the tangent squared of theta is equal to 1, which implies that the tangent of theta has to be either positive 1 or negative 1. From the unit circle, right, we know that that's going to be an answer in all four quadrants. And so if we're going to be in degrees, right, theta is going to have to be 45 degrees, theta could be 135 degrees, theta could be 225 degrees, or theta could be 315 degrees. Because one in one rotation of our unit circle, we know we're going to have four solutions where the tangent of theta is equal to positive or negative 1. Right? We know that it's going to be two solutions for positive 1, and it's going to be two solutions for negative 1. Okay? Let's look at another couple of examples before coming back and synthesizing what it is that we're doing. Right? So let's say for this problem, we're looking at solutions between 0 and 2 pi. So we're going to be in radians. All right, so if we're going to solve our equation, let's rewrite it so that we're isolating our our trigonometric function. So that's 4 sine squared of theta is equal to 3, which means that sine squared theta is equal to 3/4. If I take the square root of both sides, that means that the sine of theta must be plus or minus the square root of 3/4. Let's rewrite that so it's easy to see. All right, and that would mean it's plus or minus square root of 3 all over 2. So once again, from our unit circle, we know with plus or minus, we're going to be in all our quadrants. Just as a quick reminder, all students take calculus, all spiders taste crunchy. And so our positive solutions for sine will be when the y value is positive. The negative solutions for sine will be when the y value is negative. Our reference angle we know is going to be pi over 3 because our root 3 over 2 is where we get from our unit circle. And so that means that our solutions are going to be theta is equal to pi over 3, theta is equal to 2 pi over 3, theta is equal to 4 pi over 3, and theta is equal to 5 pi over 3, right? We know we're going to have 4 solutions on our interval. Okay? Another way that some people will think about it is to say, hey, if I have my sine function, right, and I have the square root of 3 over 2, or I have negative square root of 3 over 2, that I can determine how many solutions I have simply by graphing and plotting the intersections, then using the unit circle. All right. So one more over here. Let's have this one set up as solutions between 0 degrees and 360 degrees. So cosecant squared of theta minus 2 is equal to 0. That implies the cosecant squared of theta is 2, right? Which means that the sine squared of theta needs to be 1/2 from the reciprocal identity, which means that the sine of theta needs to be plus or minus the square root of 1/2, which is plus or minus 1 over root 2, which is equivalent to plus or minus root 2 over 2. So unit circle, right, same idea. We know we're going to be in all 4 quadrants. We know our reference angle is going to be based on 45 degrees. And so our solutions here are going to be 45 degrees, 135 degrees, 225 degrees, and 315 degrees from our unit circle. Okay, so let's synthesize what it is that we have done here and use that to discuss our steps. What are our steps going to be? Okay, first step you can think of is to get the trig function by itself and to the first power. All right, when you're doing that, you might have to factor, might need to use reciprocal identities, right? And as well, you might need to use a square root, in which case, remember that we're going to have plus or minus. Okay? So once again, if using reciprocal identity, because you have secant of x or cotangent of x or similar, right? Be sure that you set up the reciprocal correctly. All right, so example of that right down here that we had secant of theta was equal to 2, so the cosine of theta is the reciprocal of 2 is 1/2. All right, okay, once we have that, we have our equation isolated, our trigonometric function reduced, right? Then we're going to use the unit circle to find the reference angle and additional angles that satisfy the equation. All right. In that case, be sure to read the directions for radians, degrees, and or intervals, right? So am I going to be saying that my interval is from 0 to 360 degrees? Am I going to be saying that my interval is from -180 to 180 degrees, right? that is important about what we have and how we have it. Okay, and lastly, good form. You can always check your answer by substituting back into your equation. All right, but all in all, what is it that you have to be able to do? All right, you must be able to algebra correctly. Then you must be able to trigonometry unit circle correctly. If you have an error in the algebra, well, your work's going to be incorrect. If you have an error in the trigonometry of the unit circle, then your work's going to be incorrect, right? So a couple of examples here for secant of theta minus 2, right? We solved for secant of theta. Tangent squared of theta minus 1, we solved for tangent of theta, right? For sine squared theta minus 3, right, will equal 0, we solve for sine of theta. Cosecant squared of theta minus 2, right, we isolated for sine of theta, and we get our solutions. Okay, it is important that you give all the solutions in the interval if you want to earn full credit. Thank you for your time. Make sure you stick around for the next video.